The Catalan Integral. In this video, we are dealing this integral from 0 to 1, arctan of x over x dx. The best approach for this integral is just to use the series expansion of arctan of x, and then the integral becomes linear, where we can integrate part by part, term by term, and that will be easier. But first, we need to know a series expansion of arctan of x. Even if you don't know, I will derive it for you. So note that when the modulus of x is less than 1, which of course we have over here, the series expansion of tan inverse x is like this: x to the power 1 by 1 minus x to the power 3 by 3 plus x to the power 5 by 5 minus x to the power 7 by 7, and so on. You might have noted the pattern, the alternating sign of plus 1 minus 1 plus 1 minus 1, and the increasing odd powers. If you haven't been familiar with this series, we have an easy way to derive this expression. So, for deriving this, we can start with this symmetric series 1 by 1 plus x squared. So this can be written as 1 by 1 minus of minus x squared. Now if we compare this with a by 1 minus r, if you compare this with this series, then it's just a plus ar plus ar square plus ar cube and so on. But here modulus of r should be less than 1, and here also we need to have modulus of negative x square to be less than 1. That means modulus of x should be less than 1. Okay, so that's we have here as well. So now the series expansion for this will be first of all the first term is just 1, and then ar, which is minus x square, and then plus x to the power 4 ar square, and then ar cube minus x to the power 6, and plus x to the power 8 minus x to the power 10, and so on. We get that now from the geometric series for modulus of x being less than 1. We got that the series expansion of 1 by 1 plus x square is this thing: 1 minus x square plus x to the power 4 minus x to the power 6 plus x to the power 8 minus x to the power 10, and so on. Now we can integrate both sides. If we integrate both sides, this is just tan inverse x or arctan x, and this one is x minus x cubed by 3 plus x to the power 5 by 5 minus x to the power 7 by 7 plus x to the power 9 by 9, and so on. And we will also have a constant over here, in the constant of integration. To find the constant of integration, we can just substitute x as 0. If you substitute x as 0, we will have tan inverse 0, that's 0, and over here also we will have 0 minus 0 plus 0, and so on. So we see that constant is 0 from this. Now we know that we have derived the series expansion of tan inverse x for modulus of x being less than 1, and this is x minus x cubed by 3 plus x to the power 5 by 5 minus x to the power 7 by 7, and so on. So now we know the series expansion of tan inverse x. Okay, so with this we are ready to begin solving this problem. Wait, I'll just copy this in the other page. Okay. Now we have the series. Okay, so the series of tan inverse x is x minus x cubed by 3 plus x to the power 5 by 5 minus x to the power 7 by 7, and so on, and divided by x. Now again, just separate them into different terms. First we have x, here we have x squared by 3, next term will be x to the power 4 by 5, the next term will be x to the power 6 by 7, and then we will have x to the power 8 by 9, and so on, dx. Now I guess all of us can integrate this easily. We will just integrate term by term. This will be x minus this will be x cubed by 3 square. The next will be x to the power 5 by 5 square. The next will be negative of x to the power 7 by 7 square. And then x to the power 9 by 9 square. And so on. Integral is from 0 to 1. Now we evaluate this at 1 and then at 0. At 1 it is 1 minus 1 by 3 square plus 1 by 5 square minus 1 by 7 square plus 1 by 9 square, and so on. And at 0 all of this will just go to 0 since we substitute x at 0. So now we have come up in this sum. Okay, so now this sum was proved to converge at a value, can be proved easily to converge at a value, since the sum 1 by 2n plus 1 whole square does also converge, and it's just the alternating series for this sum, and its value was found by Catalan, and this is also known as Catalan's constant. So the sum is also known as Catalan's constant, and it's denoted by cap z. So the answer is just cap z for this integral, and its summation notation will be n greater than equals to 1, negative 1 to the power n plus 1. This should be n greater than 0, so that it begins with 1. Greater than 0, so that it begins with 1. And we don't need percent over here now. Okay, minus 1 to the power n by 2n plus 1 whole square. So this is the answer. It's also known as Catalan's constant z. And yeah, so this was a beautiful answer, z. Yeah. Thanks for watching. See you in the next video.